Today's lesson will have to do with the sine law. The sine law can be used to find an angle if we know two of the sides and one other angle, or to find a side if we know two angles and one side. Today we will go through how to use it. This is just the general equation. You do see that there are three. It doesn't mean that you use all three, it just means you pick any two of the three and can set them equal. So you can do sine A over A would be equal to sine C over C, or sine A over A equals sine B over B, for example. Okay, when can we use the sine law? The sine law can be used to solve an acute triangle when given the measures of two angles at any side. So in this one, we would generally be looking for one other side. Or if you're given two sides and an angle is opposite to one of the sides, and in this one we would be looking for an angle. Okay, well, let's try it out. Find the missing side. So you can see that the 55 is opposite to the E. The 75 is off to a side we don't know. The 27, well, it just said in the previous rule that the measure of two sides and an angle opposite one of the given sides. So the first thing we need to do is figure out this angle that is opposite the 27. And to get that, we know that there are 180 degrees in a triangle. We subtract the other two angles from it, and that gives us 50 degrees. So this angle is 50. Now we have that. In this question, we are looking for E. So we can say E over sine E equals 27, the side, and then opposite, which I guess before that, let's just do it with the letters to make it clear, which would be D over sine D. And let's fill in what we know and what we don't. E over sine 55 equals 27 over sine 50. And we get E over 0.819 equals 27 over 0.766. Again, we take this and we cross multiply it up here, so it'll become multiplied when it comes over. So we get E equal to 27 times 0.819 all over 0.766. And we get E equal to 28.8. We look back in the question at the units, and it is millimeters. And just to make the answer stand out, I will put a box around it. Let's try another example. Find the missing side. So again, very similar to the last one, we have 49 across from A, actually it's almost the same question, 61 across from a side we don't know, and 30 across from an angle we don't know. So we take the total number of degrees in the triangle, we do that subtraction, and we get 70. Well, we are looking for A, so we can say A over sine A, so A and sine A. And then we're going to use 30 and 70, so we would say B over sine B. We then fill in our numbers. A over sine 49 equals 30 over sine 70. We eliminate the signs in the calculator by just putting them through. So sine 49, we get 0.755. Sine 70, we get 0.940. And again, we will cross multiply the 0.755 up here, so it will become multiplied when it comes over. So we get A equals 30 times 0.755. So you can see, after you set it up, it's nothing more than manipulating an equation or rearranging a ratio. To get that, we would get A equal to 24.1. We check the units, centimeters, and we put a box around our answer to make it stand out. Let's try now a couple of problems. In triangle RST, angle S is 83 degrees, R is 53 meters, and angle T is 26 degrees. Solve the triangle. Round each side length to the nearest meter. So we know angle S is 83, angle T is 26, and we're told side R is 53. So we'll need to solve for T, we'll need to solve for S. But to begin, let's solve for angle R, because quickly we can go 180 minus 83 minus 26, and we get angle R at 71. So that is that solved. Now all we have left to do is solve for S and for T. I'm going to start off solving for S. S over sine S equals R over sine R. S sine S is sine of 83. R is 53. And 53 over sine 71. So I get S I'm just going to quickly in my calculator go 53 divided by sine 71. I'm going to get 56.1. And then I'm going to remember to cross multiply this up. And I'll explain why in a second I did that. I get S equal to 56 meters. And we were asked in the question just to go to the nearest meter. And when I come over here, I'm now going to have to solve for T. Well, T, I'll do it in a different color. T over sine T equals R over sine R. Whoops, that should be a lowercase, because remember sides are denoted by a lowercase. Well, when I set this up, R over sine R is much the same as I had here. So I know, in the end, I could just write 56.1 in to replace that. So I get T over sine T, well, sine 26. Equals 56.1. So by doing the math here, 53 divided by the sine of 71 and getting 56.1, I was able to save myself a bit of work in the end. T equal over 0.438 equals 56.1. Now due to space, I'm going to bring this up and multiply them. I'm just going to write the answer for T down here. T equals 24 meters. And I'll put a box around it just to make it special as an answer. Problem 2. In DEF, angle F, this triangle needs to be labeled DEF. Angle F is 35 degrees. F is 42, D is 64. Now we're asked to round each side length to the nearest meter and each angle to the nearest degree. So in this case, we have to find E, and we have to find angle D and angle E. So I'm going to start off looking for angle D. So I would say sine D over D equals, and I know in this triangle angle F and side F, so I'm going to say sine F over F. Well, sine D would remain sine D. D is 64 meters. Sine F would be the sine 35 over F, which is 42. So I get sine D over 64. And again, I punch this in sine 35 into my calculator. I divide it by 42. I get 0.0137. And then I'm going to take the 64 and multiply that in there by cross multiplying it up. So I get sine D, and I'll probably just write the answer this time, equals 0.877. If you need some help, call me over and I can explain this to you. And then finally I can say D equals the inverse sine of 0.877. And I get angle D equals 61 degrees. Now at this point, if I know angle D is 61, I know angle E will be 180 minus 35 minus 61, and I would get 84. The last thing to do is solve for sine the last thing I need to do is solve for sine E. So E over sine E equals, and why wouldn't I use F over sine F? They're the two given in the question, so I'm better to use that. So I would get 42 over sine 35 E sine
Ms. Townsend, please
34.
call extension 2330. Ms. Townsend, extension 2330, please.
E, and this time I'm just going to go ahead and solve it. I get 73 meters. I'd recommend you try in your calculator, see if you can arrive at the same conclusion. And that should be enough for you to proceed in using sine law. Now there will be some problems where you need to draw and try things on your own, but I think at this point you have the tools to move ahead. Good luck.